Hi, everybody. Today we're going to talk about migrating to Karpenter fast, reliable scaling. So this is the table of contents today. We'll be talking about the background, pre-Karpenter scaling, problems, why Karpenter, the migration on architecture, and lessons, and future, and Q&A. Just a quick intro, I'm Francis, and I am a staff software engineer at Coinbase. I work on the compute team, which manages all Kubernetes clusters at Coinbase. Let's dive into the intro and background of Coinbase. So we run approximately 160 EKS clusters, and we were running previously on EKS managed node groups and also cluster-autoscaler. We did have Karpenter at that time, but new, and we were on the V1 alpha and V1 beta resources, and this was only primarily for workloads that needed additional isolation. But at some point, when we completed our migration about a year and a half ago over to Kubernetes, we started to hit limitations on cluster-autoscaler and also EKS managed node groups themselves. Just some context of how our clusters looked like back then. Each cluster would have its own managed node groups, and this would comprise of different ones for infra, different ones for main service loads and whatnot. And under the hood, if folks don't know, under EKS managed node group, an autoscaler group is attached. And cluster autoscaler was actually in charge of changing the autoscaling group when a certain threshold was hit. And so for this, you know that for every node group that you want to support, you have to create a separate node group for every instance type, which is pretty annoying. You're going to have to manage this. Say, for instance, we have 160 clusters. That's just a ton of stuff to manage. And on average, when we saw node provisioning come up, it took about 4 minutes. This is assuming there's no capacity at all on the clusters themselves. So this is kind of the diagram. You can kind of see here is the EKS cluster, and we have some, this is just kind of a very generic one where we have a main node group with the autoscaling group in each of these EKS node groups. And once a certain threshold is hit, it's going to make a decision and figure out which autoscaling group to scale. All right, so let's dive into some of the pain points we had and why we started hitting these limitations and what was like kind of the root problem for us. So slow responsiveness, we saw kind of issues with scaling up and down. That was not really that fun. You would see this hit when we kind of had our load tests. It worked great when we started, and it was a very good solution. But as we migrated more and more services over, we started to hit some of these limitations. Again, the rigid instance definitions, you have to create a separate node group for every single instance type you'd like to support. That was not super manageable and not amazing to do because you would have to figure out which is the best instance types, what kind of workloads would you have on there, how do you optimize for bin packing and whatnot from an instance standpoint. Which then led to like cost inefficiencies. It's really hard for you to tinker every single cluster to make sure that this was kind of the ideal solution for every single cluster. That would just be a ton to manage. And operational overhead, for us, this was actually a huge pain point. We do cluster upgrades about 4 times a year, and if any changes on the launch template happens, a node group has to get updated. And what that means under the hood is when a node group gets updated, it's going to randomly choose a node in that ASG, and it's going to attempt to drain it in the 15-minute interval or 15-minute window, and if it fails for some reason, then that node group fails. And so it's very non-Kubernetes native in that sense, and it actually ends up us wasting a lot of time to forcefully kind of drain these nodes and get it onto the new version, whatever it might be. And we spent a lot of hours on this, and this was probably one of the big pain points for us as a team with cluster upgrades, any node group updates, and so forth. And the last point here is around auto AZ rebalancing on ASGs. This is something we discovered in some of our load testing, actually. So for folks who don't know, AZ rebalancing is actually turned on automatically on all ASGs. It's not part of a node group kind of mechanism. And when this was actually turned on, the issue that you see is when you scale up a ton of nodes and then you cut the traffic, nodes are going to scale down, obviously, and get drained by cluster-autoscaler, but the ASG has an AZ rebalancing. So if you had nodes there are more nodes on a specific AZ, the autoscaling group is going to automatically try to provision and kill nodes on other AZs, and it's not going to respect PDBs because ASGs have no mechanism or knowledge of PDBs, and they're not aware of that all. And this was like a huge issue for us because you had PDBs, but that would be doing nothing for it. And in order to combat that, we actually have something running that for every single auto-scaling group that is created by a node group, that process is suspended, and that's automatically turned off across the board when node groups were created. Cool, let's just go into some quick stats so you kind of know what you're working with here. We had our first production cluster in March of 2022, and just current to this day, we have 87 production clusters, 62 development clusters, and 165 total clusters. We're peaking at about 18,000 nodes, 514,000 CPUs, and at this point in time, the average time for a pod to get scheduled was about 30 seconds. This is kind of different from what we saw earlier, where the node took a long time to provision, mainly because we do have additional capacity that acts as buffer on our clusters. Cool, let's jump into Karpenter itself and why Karpenter, what else about it. So it's dynamic, no predefined node groups, which is awesome. We don't have to go manage 5, 10 node groups on a cluster. And it actually chooses the optimal instance at runtime, which is really nice for us, and we don't have to go figure out which one makes the most sense here. Should we do one that's more memory intensive or CPU intensive or whatever it might be. So that has been huge for us just from a management perspective of our clusters. It's also fast. It provisions nodes in seconds. Just the controller itself and how the algorithm works with Karpenter itself is able to help us kind of quickly decide which one makes the most sense versus cluster-autoscaler. When it did make decisions, it would kind of go across the different ASGs that were available, and it would try to run simulations to see which one makes the most sense for that. And also, I forgot to mention this, but with cluster-autoscaler, also had to have time for the auto-scaling group to have the lifecycle hooks on the instances and so forth. It's also open source and actively maintained. When we first used Karpenter, it was kind of still more in the beta stage and everything, and throughout the time, about 3.5 years ago now, things have really progressed super far, and you can see that like there's just a lot of support out there, and people love using this for really, really good reasons. And there is also, this is kind of asterisk of multi-cloud support. Karpenter, it's only on AWS, but there is a preview mode in GKE, I believe. So that would be so nice to have one solution across the board for all clouds. Well, I'm not sure about Azure, so don't quote me on that one. So it'd be really nice to just have one solution across the board rather than having to maintain different solutions that how do we do cluster upgrades and that kind of behavior, and not have to like learn all these things whenever you move over to a new cloud. Now let's dive into how we actually ended up designing this and our migration in itself. So we actually created a custom controller that reconciles on a node class that then creates the Karpenter node classes themselves, and it actually pulls a bit of configuration values from a config map itself. The reason being of why we actually implemented a controller itself and did this dynamically was because, let's jump into the next slide. Some of the main drivers were subnet tagging. There is a mechanism kind of for you to like tag your subnets across the board and have Karpenter node classes to manage that. but there were some inconsistencies in our behavior about how our infrastructure was set up. And so it was really nice for us to dynamically figure out these values and if it ever change, or say you wanted to exclude a specific AZ, this was also really nice for us. And the second thing is also around security groups for us. We have a very specific setup that this was really good for us to use. And the config map portion of this actually is we just have AMIs in there and some kubelet configurations. This was just a mechanism because we had to do AMI upgrades and whatnot, and this was config map, you could argue, is not the best solution, but it was something that we designed initially, and it's been really nice for just rollout of upgrades and whatnot. So that's kind of the abstraction that we ended up going with. I think you can obviously extend it a lot more if you wanted to, but at this point in time, it's worked for us. So that's kind of the high overview there. Now let's jump into the node pool configuration. This is actually a very generic node pool that we have on our clusters. And what's really nice about it, you can see Karpenter honestly exposes a ton of configurations and whatnot that you can tune. So right here specifically, you can see there's an instance category where you support C, M, and R types here, which you can define. And if you even wanted to go down the nitty-gritty of the instance families, if you want to support newer versions or older versions, you can also add that in. And the instance CPU is one that's kind of tricky. You don't want to go too large because there are nuances with having nodes with really a ton of CPU. That's kind of tricky in the sense that you end up having a ton of workloads on there. And if anything goes wrong on that node, then you're impacting a ton of pods and how those workloads work. But you also don't want to go too small because we actually ended up running into a lot of IP issues. I don't know if folks have IP exhaustion, but we ran into that a lot. So it's kind of Goldilocks kind of thing of how big should I go, how small should I go, and what makes sense is obviously a lot of trial and error. And we saw a lot of this when we were running our load tests, and IP exhaustion was a thing, and probably still is a thing. And then you can obviously, what kind of instance type, on demand or spot and so forth, and the architecture type. The disruption itself, generally speaking, I think we have just consolidation on for when it's empty or underutilized. There is some caveats with this if your service owners are not used to their workloads being disrupted. There's two more fields I don't think I could have fit in on this slide, but you also want limits on there. Having limits on your node pool is just better. You can have a really high limit, but you don't want something that just explodes in the node pool and just creates a ton of nodes unless it's warranted for. And disruption budgets is actually one of my favorite things. So here at Coinbase, we have workloads that shouldn't be or can't be disrupted during certain hours and whatnot. And having the ability to tune that across node pools is really nice because we kind of just used to be okay, it's this time. We can't go do a node group update because it's this time frame that we just can't have any disruptions on the pods that are running on the node groups. So this is just kind of what a generic node pool configurations are. Obviously, you can tune this to whatever you need. I do think Karpenter does recommend having as little node pools as you can, just because it's easier for bin packing, scheduling, and the algorithm itself to run. Now let's just kind of jump quickly over the timeline of things, what it looked at Coinbase. 2024, Q3, that's when we started doing the design. The TDD was written and scoped out, and then Q4 of 2024 is when the controller was written and it rolled out to our alpha clusters and let that bake in. And 2025, just early this year, Q1, that's where we started doing the migration across all our clusters. And this was kind of done in a very gradual way to make sure that nothing broke and nothing was unexpected, allowing a lot of bake time so that services were not knowing that this was happening, which is great because when services know that they don't know about this, it means that you're doing something good, hopefully, and nothing's breaking there. So that's just a high overview. Let's dive into lessons learned, because I think there's just a ton of things that we learned on our end. Node drift consolidation is a huge one. This is just something that I think if you were on managed node groups before with cluster-autoscaler, you just don't experience disruption that often. You maybe see it like once in a while. There's like your pods never move, and people are really cool with it. But when we introduced Karpenter, we got a lot of questions. Why is my pod moving? Where is it going? Like, I have alerts on these. It paged me. I was like, why do you page when your pod moves? But that's all right. So anyways, it's kind of the thing where you have to like teach your engineers again of like, it's okay for your pod to move. And in fact, I actually think it's great if it can move, because it means it's more resilient than other things. And so that was like a huge thing for us to make sure we have docs and everything around it, and for answer people's questions. The second thing was that around stateful and stateless workloads. I think this goes across Kubernetes, not just Karpenter itself, but kind of finding a mechanism to tune workloads that were long-lived or needed more time and couldn't be disrupted, and kind of figuring out a good middle ground of like, what's gonna block us operationally to do cluster upgrades and what's not, but also meet the criteria of what users needed and wanted. So for instance, for us, like something like a cron job that runs every whatever the schedule is and however long it runs for, you can technically add the Karpenter do not disrupt annotation, which would not allow that pod to get disrupted. And that's probably fine as long as this job doesn't run for like a really, really, really long time. That's up to you what that means. And so it's kind of figuring out a good middle ground of like what makes sense for your services, and having those things carved out. So IP exhaustion is another one that we mentioned, and this still kind of ongoing, but for us, having this ability to have a EC2 node class created with new subnets that we add is really nice, because I remember in node groups, could be wrong if this is not true anymore, but having to like manually go add those ones in Terraform for us and everything, it's not really fun. And if there is a good tagging behavior and mechanism for you to add that into Karpenter, you can just automatically pick it up, and I don't have to go worry about making a ton of changes across the board. So that has like worked for us pretty well. I think we still have some IP exhaustion stuff, but that's the main thing there. And then setting CPU and memory limits, I mentioned that previously. So I just think it's good to set those. I think there are certain ones that don't have those set for reasons, but typically I think it's just better. And then the observability piece, this was kind of done for us when we learned about certain metrics, and Karpenter's actually released a lot of cool metrics for us, so I really love that. And like having a dashboard, having runbooks, making sure we know what happens and the team is educated around all of that is like super important. So that's kind of the lessons learned. There's probably a few more, but those were the main ones on our side. Cool. Now, just for the future roadmap, kind of just threw a few things in. So we don't use spot instances currently, but it would be great to expand that usage and like look into that. The second thing is around integrate dynamic pricing signals into EC2 node classes. I know node overlays was introduced recently in the last version or the last two versions, but that would also be nice. But I think there is an issue that we have around it. But yeah, that's kind of the one. And the multi-cloud support itself, again, I think most companies want to be resilient to cloud outages, and we would prefer to have like across the board support and just one solution. I think that's true for any kind of solution if you manage clusters when you have a lot of different clouds. So kind of the TLDR of this is Karpenter unlocks speed and simplicity, but it's really, for us, the power came from the automation around it, and saving those countless hours we had was just managing node groups and cluster-autoscaler itself. Cool. Thank you. Any questions? You might have to turn it on if it's not on.
Hello, thank you for the talk. I have two questions for you. In your case, where you are deploying Karpenter, is that node pool also managed by Karpenter, or that's managed by Autoscaler? And do you see any issues with that?
Yeah, I think I've totally missed that point on my slide deck for some reason. But yeah, it's not on Karpenter. We have managed node groups. Karpenter deployed onto managed node group just because if Karpenter's managing Karpenter, if something goes wrong, you're kind of screwed. So we just have that. And I don't know if I caught your second part of your question.
I have a follow-up on that one. Have you experienced any issues? Have you tried it managing, or you just decided not to do it outright?
We just decided not to do it that way. I know EKS has a managed Karpenter, but that's on EKS auto mode. So yeah, I don't think they're ever going to go over to just regular EKS.
So you have a mix of Autoscaler that's managing Karpenter and the rest of it by Karpenter.
Yeah. So actually, just for some context, all our infra workloads are still on managed node groups, and all the other ones are on Karpenter, just for stability purposes for us for now.
Got it. And can you share more insights about how you managed to move your workloads from Autoscaler managed ASGs to Karpenter node pools and EC2 node classes without any downtime? Like how you begin to tag your subnets slowly and shift your workloads, affinity, and taints and toleration if you use them to make sure the nodes scale up on the Karpenter nodes, but not on the Autoscaler group without any disruption and without capacity constraint, because we might not have 2x the capacity to have both of the stacks running at the same time, right?
Yeah, for us, we slowly started to scale down the node groups. Our node groups were typically set at the max of 450 nodes. And you can start scaling that down and down and down until it's like 0 and still have Karpenter running. These are obviously for workloads that had no taints or toleration on them. The taints and toleration ones that we actually had, a good bunch of them actually were on Karpenter before, so that wasn't as much of an issue.
Got it. And any other challenges have you faced with Karpenter, or limitations with consolidations or drift? Are you enabling drift feature in Karpenter?
Not too much besides just like service owners don't expect the disruption being super frequent.
Got it. Thank you so much.
Yeah, no problem.
So that's a great segue for my question. So we deploy Karpenter for a large Kubernetes environment, and we've got hundreds of applications running on it, and disruptions have been much more frequent. I'm curious if there's any like settings or configurations you've had to enable to try and clamp down on that aggressiveness, or if just do not disrupt annotations or pod disruption budgets are simply good enough. Just curious what you've had to do there.
Yeah, we actually introduced recently a low disruption node pool that I totally forgot to mention, but you kind of set the disruption budget to be much lower, and also I think we have some disruption budget of like certain time frames that's not allowed to be moved. And that has been pretty nice. There was a new feature, I think, around the static node pool on the newest one. I don't know if that's worthwhile, but it's going to come with a cost because you can't move the nodes stay statically at one value. So that might be worthwhile depending on your workloads.
Okay, cool. Thanks.
No problem.
Hi, thanks for the talk. I'm interested in the controller that you wrote along to wrap around the node pools and EC2 node classes. We also run Karpenter and more or less struggle with the subnet discovery and security group discovery that I assume that controller problem is solving. How disparate are your node pools? Like how many node pools do you end up running there, or EC2 node classes? Because we're at like 5 or to like under 10. So interested in how that controller manages those and what the kind of different requirements are.
Yeah, the number of like node pools, I think we generally run about 3, maybe 4 node pools on most of our clusters. And that's just managed separately, not from the controller. So the controller is only in charge of creating the EC2 node class itself. And with that one, actually, I think we have 2 EC2 node classes because there are some of our clusters are public subnets, with some of them are private. And so that's kind of how it's worked. I don't know if that actually answered your question. So
No,
feel free
does.
to follow up. Okay.
Yeah, also, just let you know that We run Karpenter on Fargate, and that's been working really, really well for us. So just for the audience, something to consider to not have Karpenter manage itself.
Okay, awesome. Thank you.
Hi, I was curious about, you had an example up of a node pool where you had kind of mixed families within the same node pool. I was curious how if you had any issues with, is that normally how you run things, I guess, first of all, in terms of like mixed families within the same node pool together? I guess as background, I'm coming from an environment where we have our own like custom auto-scaling, custom node organization where we just have things split by like pretty strictly between families. I was curious how you dealt with like mixed families and how you organize the workloads across them.
Yeah, I think for most generic workloads, just the families that you saw up there were memory intense, CPU intense, and just a very generic general instance type. And that hasn't been an issue for us to schedule. You can also add a node affinity on your workloads if you wanted a very specific instance type, and that's respected by Karpenter and whatnot, and it will take that into its scheduling requirements.
Okay, so you normally have the workloads like tagged with particular families if they expect certain like CPU speed or that sort of thing?
Yeah, they do need that. But there's also one separately where there's like some different constraints, so they'll have their own node pool there. But ones like I think I'm talking about 80, 90% of our workloads can fit in that generic node pool that was posted there.
Got it. Okay, cool. Thank you.
So, no problem.
Hi, thank you for the talk. It was great. Given there's no min size on a node pool, how did you prevent consolidation during an incident?
I think we always have things running, so I actually have never seen us ever scale down to like 0 or anything on our node pools. Yeah,
You had a slide that said during the USS1 outage, you had to prevent consolidation.
Oh, yes. Oh, my God, I totally missed that point. Yeah, so that's lessons learned. But yeah, so what was really nice about that actually is that because we had a bunch of fleet running and whatnot, instances running, we were just able to edit across the board all the node pools in every single cluster. That was important for us to remove consolidation to 0, essentially.
Got it. All right,
Yeah.
thank you.
Yeah, no problem.
Thank you so much for the talk. You touched briefly on stateful versus stateless workloads to basically have less disruption on obviously the stateful workloads. You also touched on it's a good thing for developers' apps to start moving. The more they move around, the more tolerant they are to and more resilient. Were there any techniques and kind of FAQs that you learned to help the developers make their workloads more tolerant to that kind of movement, less disruption, less dropped requests, things like that?
I don't know if we had like an official guide of how to do it, but we did have like an FAQ around like disruptions are expected and whatnot, and also have like, I guess we have some AI with our bots telling them that it's also expected. So I don't know if there was like an official like recommendation. We did have like a new library we wrote around singletons, because singletons are not great in Kubernetes, and having a leader-based, I think it was a least-based leader election that we have added there as a recommendation there.
Okay, yeah. Like I was thinking like lifecycle hooks and things like that to drain, ingresses and things like that. But okay, so leaders and okay, thank you.
Thank you. I have two questions. The first one is, what is the major purpose of the custom controller? Without custom controller, were you not able to migrate to Karpenter?
We were able to. It would just be a lot of management across all our clusters and like a lot of YAML files likely, and it wouldn't have been as clean for us. Like it would just been a lot of hard coding probably, and that wasn't ideal for us.
Okay. The second question is, have you tried AL2 to AL2023 migration in the Karpenter?
Can you repeat that for me, please?
Amazon Linux 2 to Amazon Linux 2023.
Oh, no, we're on BottleRocket.
Okay, thank you.
Hi, we're having some interesting issues after like heavy scaling events when we scale back down with Karpenter not choosing like more effective node sizes and bin packing pods more correctly on nodes. So like we scale up 10x in the cluster and then we'll scale back down to several nodes, and it's choosing like 5 C6s, or rather than like a more effective larger node and bin packing them? Is that something you've experienced?
I think because we have such a various wide of like different kind of workloads, I don't know if we've seen that. I don't know if anybody on my team has seen that, but we personally haven't seen it. But yeah, I don't know if it's something that we've seen on our side yet.
Okay, thank you.
Hey. Before you are using the Karpenter, I think you are using the autoscaler.
Did I tune out the autoscaler? Is that what I heard?
Yeah, I wonder that. Are you initially using the Karpenter, or you migrated from something to the Karpenter? My question. That's my first question.
So just to make sure I understand your question, you were asking if we tuned a cluster autoscaler at all before using Karpenter?
Yeah.
Okay, yeah, we use everything pretty much out of the box. I think we only tuned it when there were any issues and like let that bake in before. So when we initially had it, we didn't tune it at all.
Okay. So what is the key part, do you think, that drive you to move from the from the autoscaler to the Karpenter?
I think, yeah, the big issue for us was actually maintaining upgrades and like node group updates. That was like a huge pain point for us. And just maintaining node groups is not that fun to like figure out which instance type you want to support, and having knowledge and context there. So that was the main driver for us.
And the Karpenter can save you from upgrading those nodes, or?
No, it still upgrades it, but it's like much smarter with the way it upgrades it than how we had to manage that life cycle.
How smart what is smart part?
I mean, it's run in like a controller fashion where it like detects the drift and it's going to try to drain the node outside the disruptions and so forth. What a EKS managed node group, we had to go manually get this applied, and it would try it once. If it fails, we'd go try again. So you kind of had that manual intervention for us. So that's kind of why we moved over to Karpenter.
Okay.
I think we might be at time, so I don't know. I don't know if there's another session going on. So maybe we'll call it here. Awesome. Thank you.